Okay, so we're going to get into another way to solve quadratic equations. That's using the zero factor property. The zero factor property says if A times B is equal to 0, then either A is equal to 0 or B is equal to 0. This means that if one side of our equation is factored, and the other side of the equation is 0, then you can set each factor equal to 0 and solve. This is also known as solving by factoring. Even though we're using the zero factor property, a lot of people just call it solving by factoring. But unlike the square root property, where we have the quantity squared on one side and the numbers on the other, you have to have one side equal to 0 and one side factored. It's called the zero factor property for a reason. Zero factor, zero factor, zero factor property. Okay, so in our first example for the zero factor property, we have 2x squared is equal to negative 3x plus 9. The first thing we need to do is get all of our terms onto one side. And because we will be factoring and we don't do negative leading coefficients, and I don't want to have to worry about a GCF, I'm going to move my right-hand side stuff over to the left, which means that I'm going to wind up adding 3x to both sides and subtracting the 9. This means that I have 2x squared plus 3x minus 9 equal to 0. Okay. I'm going to solve this method using the bottoms up method. Some institutions also call it like slide, divide, slide. Okay. And if you need additional help with factoring, please check out the factoring videos that I've included. Here we go. The bottoms up method means that you have to identify what A, B, and C are in your quadratic. Here A is 2, B is 3, and C is negative 9. There is not a GCF. If there were a GCF, I would need to take that out first. But the 9 doesn't have an X, and not everything's divisible by the smallest coefficient, which is 2. Because I don't have a GCF, go straight into product and sum. We're going to be looking for the product, that's multiplication, of A times C, which is 2 times negative 9, which gets us negative 18. And we're going to be looking for a sum, that's when we add, of B, which is 3. So we're looking for two numbers that multiply to be negative 18 and add to be 3. If I start just with the numbers that we were given, the A and C, 2 and negative 9, we know multiply to be negative 18. But when I take 2 plus negative 9, I get negative 7, which is just not what we are looking for. So we keep going. You could do 1 and negative 18, but that's going to get us an even bigger number when we're trying to get to 3. So the next number up from 2 is 3. 3 times 6 gets me 18. And if you're not seeing where these numbers come from right away, if we were to take 18 and then we've already had 2 and negative 9, so the next number up from 2 is 3. 18 divided by 3 gets me 6, which is why I can include 3 and 6 in my list, but I need a negative 18. So one of these numbers needs to be negative. When I take 3 plus -6, I get -3. Right number, wrong sign. So I'm going to go back and flip my signs in the two numbers. So instead of +3, I need a -3. Instead of -6, I need a +6. And now 3 plus 6, sorry, -3 plus 6 gets us to our +3. So we found our magic numbers. After you find your magic numbers, we're going to write our factors. We had x in our equation, so I'm going to include x in both of my factors. I have a -3, so I'm going to have -3. I have a +6, so I'm going to put +6. And my next step, this method is called bottoms up. To have a bottom or a fraction, we need to have some division. So we need to divide both of these by a. Remember we said that all the way back here, before we found the product and sum, a was 2. So we're going to divide both of our constants and our factors, or the numbers in our factors, by 2. Simplify our fractions. When we take 3 divided by 2, it gets us a decimal, and 3 over 2 doesn't reduce. So I'm going to leave my 3 over 2 alone. When I take 6 divided by 2, I get 3, which is a nice whole number, not a fraction. And this method, remember, is bottoms up. What that means is after you reduce your fractions, if there's still a denominator, it needs to move up. So we move our bottom up. It's like he's moving out of the basement, not out of the house. So don't kick him out of the parentheses. He's still in the parentheses. It's just now, instead of being in the basement underneath the 3, he's hanging out with the x. So we have 2x minus 3 in the first factor and x plus 3 in the second. We're officially done factoring, but remember this problem asked us to solve. When you solve, you need to have x equal to a number, y equal to a number, whatever your variable is, equal to a number. Remember that we had our equation equal to 0. So we are going to set our equation equal to 0 again. And by doing that, we're now set up for the zero factor property. Left-hand side of our equation is factored, right-hand side is 0, which means that we can set each of our factors equal to 0 and solve. So solving our first factor equal to 0, the 2x minus 3 equal to 0, add 3 to both sides. We find out that 2x is equal to 3 because the -3, +3 cancel out. When we divide both sides by 2, we find out that x is equal to a +3/2. Leave your answers in fraction form unless the problem asks for decimals or if you're talking about money. And we know this doesn't reduce because we already did the 3 over 2 in our calculator. And much like in the other instances, I'm just using the Desmos calculator. If you have not written it down, it is a free web page. They have the graphing calculator. This time I'm just using the scientific calculator. There's also a Desmos app that I really like. All right, we're not done because our highest exponent was 2 and we only found one answer. Still need to find the second. We had x plus 3 equal to 0, so we need to subtract 3 from both sides of our equation. Left-hand side, the threes cancel, and we find out that x is equal to -3. Remember, your exponent, the highest exponent in your equation, is how many answers you should have when you're done solving.